Assalamualaikum warahmatullahi wabarakatuh. My name is Marsha Rahim, 8180131. I'm a Designees group for potato chip cutting machine. In Chapter 1 Introduction, we know that potatoes are a major food crop first cultivated in the Andes of Peru and Bolivia. It started to industrial consumption in 20th century. We need to imported the potatoes due to the scarcity of local farm in Malaysia. Potatoes are more significant vegetable crop and it widely consumed staple food in global agriculture output. The objective and scope, we need to create a lightweight potato chip maker that have two main processes, which is slicing and grating. Capacity to cut and grate to a uniform thickness and to produce a different type of output, which is oval and straight cut. These are the logos and the organization chart for my team. This is the flow chart, which we have to do a literature and design a machine, and we need to make an analysis result for our simulation, and then we have to calculate and make a final report. The detailed design process model have three stages, which is conceptual, embodiment, and detailed design. For chapter 2 define tasks, we have the three pattern search that we need to compare with. From the Google form result, we knew that this respondent did not get the same thickness and diameter for the chips, and they all agreed to have a portable and fascinating machine. The respondent also disagreed on operating, maintenance, and marketability costs for the machine. The objective 3, we have 4 main objectives, which is design, cost, features, and ergonomy. The RL or engineering design specification, we knew that one person need to move the machine, so it must be untransportable. The time should be adequate for an intermediate task, and the machine should not be overly heavy.
Assalamualaikum. My name is Muhammad Fuad bin Majid, 8180014. For chapter 3, conceptual design, component and function decomposition analysis. This is the potato chip cutting machine for the power source, body frame, and moving mechanism. As you can see, this is the product sketching, design 1, design 2, and design 3 for the potato cutting machine. For the function structure and concept generation, as you can see, from input, main, and output, electrical energy converts to mechanical energy. The motor driver will rotate the driver mechanical component, shaft, and blade cutter, and approximate equal size potato chips in thickness and diameter. For the concept evaluation, there are 11-point scale and the description. And the concept selection, body, wheel, shaft, and blade cutter.
Greetings and Salam Jatra. My name is Bastian Skid and my matrix number is AD180040. And now I'm going to present the chapter 4 for the embodiment designs and analysis for our group project, which is the potato chips cutting machines. The figures below shown in the slide is first is schematic diagrams, and the second is raw geometry layer. As you can see in the schematic diagrams, you can see the energies from the human metals was first put into the switch push buttons on the machines, which is known as the control panels, where the raw material was inserted into the machines. And the second one runs by electrical energy. The motors was runs, which is involved in the mechanical energies, and all the driven components were rotate, which is involves in transmitting movements. Next is about the actions of the machines. The action of the machine is specifically the potatoes or raw materials entered the cutting chambers, which is known by the inlet. And lastly, the materials will go into the output, which is the material obtained was into chip size, and the potato cuts by the rotating multiple blade cutters. Next part is about the interaction and notifications when running the motors, which is known as the summarize for the movement involved in the motor, which is by control panel. Next is by through transmitting movement. Next is by action, and last is go to the output. Output on these machines is by the chip size of the potato, which is cut by the blade cutters. The next part is the body frame analysis, which is known as structures body. This is for body frame and types of analysis: force analysis, buckling analysis, fatigue. The materials was determined to be stainless steel and value to be determined, such as affordable, rust resistance, lightweight, easy to operate, and durable. For the cutter analysis, the design of the body frame is shown in these figures, and the type of analysis is same with the body frame analysis. The materials same with determined with stainless steel, and the values to be determined is able to cut the potato without harm the potato into an almost the same size of the chips. Besides cutter analysis, body support analysis also involves in the designations of the machines. The figure in the side shows about the design of the body support, and the type of analysis is exactly same with the cutter support. Materials is determined to be stainless steel, and value to be determined is able to withstand the stress to provide better stability for the machines and actually is able to move it easily. Specific components in part that involves in the rotations and mechanism movement of the machines, which is include bearing, which is quantity 4 bearings. Next is the shaft, which is consists 3 shaft. Next is gear set. There are 2 gear set was involved installed in the machinery, and lastly is about the nuts. The standard models for the on the machine is first is the body frame. Quantity is 1 cutter, which is designed for 3 designations blade. Next is the potato collectors, and for the cutter grippers it just installs 1 quantity. Next is about the list of special purpose component. The machine is also involved in the special purpose component such as shaft connectors and electrical motors. When designing some machineries, especially potato chips for cutter machines, there are several considerations for the design. First is about the safety, especially for prioritize low speeds and high speeds maximums. And second one is about the shield cover. It is actually to protect for the manual operator when operating the machines. Next is about the designs for functions, which is known as mechanical engineering design element. And next is sustainability elements such as environment, socials, and economy. The design that also need considers is about designs for reliability, like designs for assembly, ergonomic considerations, published standard, and lastly is about the design for environment. That's all for the part chapter 4. Thank you very much.
For chapter 8, economic costing and business plan. The standard component procurement and manufacturing costs. As you can see, the overall cost is 1,343 ringgit and 29 cent. For the total cost for the manufacturing cost, 470 ringgit, and the fixed cost is 487 ringgit. The executive summary: the partner, collaborator, materials corporation, manufacturing firm, and the cost structure revenue stream. Company background and product description. The company name, the Designees, and the product is potato chips cutter machine. The motor power is 0.75 kilowatt. The product dimension height 125 cm. The width is 68 cm. Length 85 cm. The weight is total weight 125 kilo. Warranty period 5 years. The SWOT analysis, as you can see, the strength, weakness, opportunity, and threat.
Hi, my name is Gina Vitoni with metric number 81A0052. Today, I will present my part, which is chapter 5 with the design and product simulations. As you can see here, this is our full assembly of our product, which is potato chip cutting machine. There are 25 parts of this product. This is a detailed drawing for our parts of potato chip cutting machines. Okay, let's move to the simulation analysis. First of all, we do the simulation analysis at main structures according to the von Mises distributions. The color of red represents as the critical value, meanwhile the color of blue is represent the safe areas. So, from the result of stress distributions, the maximum value of stress distribution is 6.38 exponent negative 3, and the minimum value for stress distribution is 1 exponent negative 3. The right figure is show us the deformation of main structures. So this deformation was occur at the red color because there has a stress due to the weight of motor on that areas. Okay, besides that, we also do the static simulations at the shaft. After setting the gravity, temperature, and force, the static study was successfully performed. From the static simulation of shaft, we obtain the result of buckling, von Mises, fatigue life, frequency, displacement, and fatigue damage. The maximum value for the buckling is 3.81 exponent negative 3. For the von Mises, the maximum value is 1.796 exponent 10. But here there has yield strength result for von Mises, which is 6.2 exponent 8, which is the yield strength is greater than critical value. So this shaft is still safe. For the fatigue life, the maximum critical value is 1 exponent 6. For the frequency, the maximum value is 2.58 exponent 1, and for displacements, the maximum value is 2.283, and the last one is fatigue damage, which is the maximum value for the critical is 1 exponent 4. So that's all for me. Thank you.
My name is Nurinur Hanif bin Edison Sohma. My metric number is 810037. So I'm going to present my part, which is chapter 6, prototyping and testing. So we go for the product prototyping process. First, we establish prototype objective, which is we prototype the plan. Second, define prototype functionality. We outline the definition. Third, we develop prototype, which is we execute the prototype. And last but not least, we evaluate the prototype, which is we evaluate the report. We make an evaluation report. So this is our final prototype of potato chip cutting machine. And we go for functional checklist. First, portable, interesting design, easy to maintenance, low maintenance cost, low operation cost, safety, durability, environmental sustainability, friendly user, non-harmful substance is all checked. Next, we go for material checklist, main structure to support the whole machine, welding chamber to store the potato, rubberized machine sole to give shock absorption, legs to give the stability, grating plate to grate the potato, belt to control the grating plate, and shaft to control the belt. And testing requirement, first functional test to ensure the potato chip will be shaped according to the prototype, stress test to make the certain that the system runs smoothly, and reliability test for operate time. The prototype functionality will be defined by how consistent it is across testing, equation, and addition. So we go for chapter 7, sustainability and environment consideration engineering design. So this is our key priority in this project. So we have 3 pillars, which is economic growth, social equality, and environment protection. So the design for environment, first we design for manufacturing, we design for the workplace, we design for the minimal use of material, we design to avoid uses of hazardous or undesirable materials, and last but not least, we consider the environmental hazard of production workers. So that's all from me. Thank you.